What's that on the board?
Oh, I was thinking of lesson.
Okay, so we're doing 5, 6, and 7?
Yeah.
What?
Mr. Park, I'm very tired today.
Oh,
Boo.
and what? Teachers cannot be tired.
No,
Are you tired today?
Yes, I'm tired every day.
because you get paid. And
We get money to go. We pay money to go here, so.
Find the maximum value for a rectangular solid inscribed in the ellipsoid. Okay, look. If you have an ellipsoid, okay, let me ask you this. Did you at least get the formula so I don't have to like
Okay, wait.
discuss that?
What do you mean the formula?
Huh?
Yeah, I didn't know.
Okay, look, if you have the ellipsoid like here, like that, and let's say you have a point on the ellipsoid, x, y, z, then it says find the maximum value for a rectangular solid inscribed in there. So like side view, it looks like this then, right? So wouldn't the volume be simply 2x times 2y times 2z?
Yes.
Right? Because if that's like the xy plane, then that would be z and that would be z, right?
Oh.
Yeah, so
that
go-
makes sense.
So that's 8xyz
And then you just do the.
inscribed in the ellipsoid. So then what do you want to do? We got to solve for z and plug it in there? Okay, so if you solve for z, let's see, can we just do it in one fell swoop? Z squared is equal to c squared times 1 minus x squared over a squared plus y squared over b squared, correct? Minus like that?
I'm sorry, how do you get the 2x, 2y, 2b? Sorry.
Because if this is the xy plane and this is a point, this is like side view, isn't that z then?
I can see.
So isn't the side gonna be 2z? So in fact, every side can be like 2x, 2y, 2z, yeah?
Okay.
So you guys didn't even do this problem then?
I didn't know how to like that first step was.
The first time we
Yeah.
couldn't even get that.
I was
Okay, so if you solve for z, z is the square root of this then, right? So you're gonna have a x y, but z is the square root. I guess the c can come out, right? In fact, you know what? Why don't we simplify this whole thing? So if you get c squared, if you make a least common denominator, aren't you gonna get a squared b squared minus b squared x squared minus a squared y squared? So when you square root it, the c over ab comes out, and then you're just gonna have a squared b squared minus b squared x squared minus a squared y squared. Is that correct?
Yeah.
Okay, so now all you gotta do is compute the gradients. Now, okay, now that I did this, can you guys do the second partials test?
I think so.
Yeah, I think you guys, the rest is computation. I think you guys can do it. Number 6, a pentagon. This is kind of leading up to today's lesson right here. It's kind of problem. Is composed of a rectangle surmounted by an isosceles triangle, where this is theta and theta. This is y and this is x. So this is x. Given that the perimeter of the pentagon has a fixed value p, find the dimensions for the maximum area. Okay, now look at this picture. If this is x and this is isosceles, wouldn't this be x over 2 and this would be x over 2? Right? So therefore, how would I get this side right there? Using trigonometry. Okay, look, let's call this box. What trig equation can I write to find box? Tangent theta is not tangent theta full. Cosine theta is equal to adjacent over hypotenuse. Therefore, what is box equal to?
It's x over 2 cosine. Yeah.
Secant theta.
Oh.
Because you gotta divide by cosine theta. 1 over cosine is secant. So the box is x over 2 secant theta. X over 2 secant theta. Okay, so we want to maximize the, what are we trying to do? Maximum area. Okay, so what is the area of this pentagon? Well, duh, you got a rectangle, so that's xy. How do you find the area of this? Oh, we need this
Wouldn't it
too.
be- Yeah, wouldn't it be simpler to do that? And
No, but we also need that because they're talking about the perimeter, right, too?
Oh.
So, let's call this triangle then. What equation can I use to get the triangle? Tan theta is equal to triangle all over x over 2. So a triangle is equal to x over 2 tan theta. That's the, I'm not gonna rewrite it, triangle. So, you got the area of the rectangle, and then you gotta add to that the area of this triangle on the top, which is 1/2 base times the height is the triangle, which is x over 2 tan theta. So we got x, y, plus, if we simplify this, x squared over 4 tan theta. Okay, you guys, once you got that, you guys can do the second partials test, yeah?
Was it over 4?
Because over 2 over 2. 1/2 base times height is the
Did I
area.
get 2 of those?
Oh, the base, no, 1/2 base times the height. The whole base is x, right? That's this x here.
Oh yeah.
And the height is x over 2 tan theta. Okay, you guys heading off the ball and scored a touchdown now. Number 7, okay, this, according to you guys, this is the hardest problem, but you don't even have to write the equation. F equals ax, this is a 2-dimensional problem too. No, it's not.
Wait, sorry, so in the last one, how does perimeter, like,
Oh, so, I forgot to even do that. Okay, let's erase this one then. We're not done yet. So, it says the perimeter has a fixed value p. So look at this picture, what is the perimeter? What's the perimeter of this pentagon? X plus 2y plus 2 of these, x secant theta, that's gotta equal to p. So we can actually get rid of one of these variables by using this equation. Which variable do you wanna get rid of?
Why?
No.
Or the tan theta, maybe, yeah? No?
the secant theta?
Yeah.
Oh, like,
No, because, okay, either you're gonna get rid of the x, the y, or the theta, right?
The theta,
Yeah, but can you see it's gonna be quite messy? If
yeah,
you,
the y.
yeah, it's gonna be.
no, but then you get 2x, probably the y, yeah, I would guess. So, 2y is equal to p minus x secant theta. So y equals p minus x secant theta all over 2. Take that and plug it in for y there.
And then what?
And then you do the gradient, the second partials test thing.
But that doesn't solve for p though. No, you just.
No, p is a constant. P is the set perimeter of the thing.
It's just, you have to solve for dimension.
Yeah, so you don't have to worry about p is a constant.
Oh, it's like what we did in calculus.
Yeah, because sometimes you have constants, yeah. Okay, okay, I'll let you guys do that then.
No way, can you do it?
No, okay, no, you know what? You guys need to at least try it. Because I know you didn't because you couldn't even write this equation. So at least try it then, okay? Take this, plug it in right there, and then let's see if you can actually compute the partials.
How do you solve for x and y?
But you know what? But, say that again?
How do you solve for x and y?
No, you gotta do the second partials test.
And then.
And and here, this is my guess since it's on there. I think it's gonna be a maximum. I think D is gonna be less than 0 and A is gonna be less than 0, so it's gonna be a maximum.
Wait, if you know like a maximum, how are you supposed to like solve for x and y?
'Cause
No,
you
the
make
x,
the
no, the
gradient.
x and y has a p in it. And
Yeah, there's gonna be a P
has a
in
p
the
in the
answer.
answer because p is a
P is,
constant.
there you go.
Is that your question?
Can you just solve it? I don't know how to solve it.
No, 'cause don't you just.
Okay. Well, how did you solve the other problem? Okay, here, I'll go one more step then. Okay, so let's substitute it in. X times y, which is p minus x secant theta all over 2 plus x squared over 4. Okay, we'll go one more step then. Okay, what is the gradient What's the gradient then? What's the partial of this thing with respect to x? You want to distribute the x in here? Maybe that's better, yeah?
Yeah.
Okay, so so put the 1/2 on the outside, and then you're gonna have px minus x squared secant theta plus x squared over 4 tangent theta. So what's the gradient with respect to x then?
Half.
Okay, what do I put here? 1/2 p minus
X.
Ew.
X.
x minus x secant theta. Did I do that correctly?
Wait, isn't P go to 0 because it's 0?
No, p is a half.
if I
No,
add
because
X on
if
top.
you multiply it out, you're
Yeah.
gonna have 1/2
Yeah.
px. The derivative is p over
Yeah.
2, right? Okay. Oh, we're not done yet.
Yeah.
Plus, what's the gradient? The partial with respect to x of the second term. X over 2 tan theta. Correct? Okay, now take the partial with respect to theta now. Oy. So the first, that's gonna be 0. So you're gonna get minus x squared over 2 secant theta tangent theta plus x squared over 4 secant squared theta. Okay, check to see if I did that correctly before we move
Oh,
on.
yeah, because the tangent theta and secant theta are just constants, right?
No, not
Or
for,
not constants, but
that's the variable, that's
Yeah.
kind of like the y then, yeah?
Yeah.
Yeah. All right. Okay, so in order for this, so what's the stationary point for this? You got to set both of these equal to 0 then, right? So in the first equation, 1/2 p minus x, p is a constant, Joe, minus x secant theta plus x over 2 tangent theta, got it equals 0. And then negative x squared over 2 secant theta tangent theta plus x squared over 4 secant squared theta equals 0. And then you gotta solve these equations. That's what we did in the other problems. Except it never had trig and things like that, right?
Oh, you made this on test.
Okay, do you want me to go further?
yes, please.
Let's just move on.
Let's just move.
No, I think you guys can do it, huh? Okay, wait, okay, I'm trying to look at what, okay, so like this one, okay, look at this second equation. This one caught my eye. X squared over 4 secant squared theta gotta equal x squared over 2 secant theta tangent theta. Oh, I think it's coming out already, just like eating oatmeal, right? Multiply. Can I divide both sides by x squared?
Yeah.
Yes, because x cannot be 0, right? Because if x was 0, you would have 0 volume, right? And then can I multiply both sides by 4?
And multiply both sides by 1 over c.
Okay, and so divide both sides by secant because secant is never 0, right? So you get secant theta is equal to 2 tangent theta. And what is that like? That's 1 over cosine is equal to 2 sine over, oh, it's coming out. Here comes the oatmeal. Sine theta equals 1/2. Hey, theta is pi over 6. And then once you get theta, plug it back in to figure out x squared. Plug it back, you want to plug it into this one then?
Oh no, it's okay, I got it. I got it now.
It's just computation. The hardest part of the problem is setting it up. And then after that, look, computation, computation, computation. You know, the rate we were going, we might have to go to plan B.
Yes.
Yes.
Wait, why are you guys so behind when we have like so little bit work?
We were on, or I was on.
No, you know why you guys make this the last priority, that's why.
What?
You got all your other classes and then MVC.
I don't want to farm.
Oh.
Huh?
I'll
I
just.
want to
Yeah, 1 to 4, those are the easy ones, that's why.
I got bored.
Whoa.
Okay, let's just set up number 7 and then we'll go to plan B then, since you guys are all tired. And then you know what? We're gonna catch up in a major way because we have extended on next week.
What's
that?
Tuesday, right? What?
Wednesday. Oh no, Thursday. It's Thursday. He said Thursday.
Test is Thursday.
Next Thursday.
Yeah, so we're just gonna leave it Thursday, right? Or we're gonna extend that one day.
No, because Veterans Day is on
Okay, let's just set up number
Wednesday
7.
on Monday.
Friday. No, Veterans Day is Friday.
F is equal to AX plus BY plus C. I'll make an executive decision after we finish this problem, setting up this problem. You guys gotta at least try the algebra, like some of you didn't even try, look, try this thing over here.
Look at
What do you mean?
the algebra's insane for number 7.
Well then, I have to erase the board twice then, right?
What?
Yeah.
Okay, so what are we trying to do? It says
We
find
did
the,
that.
oh, so just maximize this function,
This is like the first
they
2
gave you the
steps.
Are you
function.
serious?
Okay, let's compute the gradient. What's the x, okay,
God.
ah, x component of the gradient, go.
Oh.
Can you distribute
Alright.
this one?
Low D high.
Yeah,
Is
low
it
high.
oh.
X squared plus y squared plus 1, and then
Low D high,
2ax plus by plus c
Yeah,
times
that.
a.
That's not
Times eight.
four.
times A, okay. All over denominator squared we go.
Low high minus high below.
Oh wait, we're not even done yet.
Yeah.
Okay, we gotta erase this.
That's
Oh.
right.
No, I remember doing this problem, but it took like the whole board. I think.
Yeah.
Yeah,
Why
why
is
are
it
you
like-
giving that to me?
Oh,
Because it's good, look at the answer, it comes out so
I haven't
clean.
personally like that.
Okay, low D high
Minus.
minus high D low, which is simply
Low.
2x, right?
Yeah.
Okay, that's good. Okay, so that's the x component of the gradient. Now what about the y component? Low,
You really?
low D high, ax plus by plus c times b, correct?
Yeah.
Minus, look, I lost my concentration already. Low D high minus, if you don't concentrate, no can do. High D low,
2y.
2y, all over denominator squared we go.
Yeah.
Okay, there you go. So just set each one equal to 0 and then start solving.
Wait, do you need to, wait, I wasn't sure. Do you need to set them
It's
equal
so
to
big.
0, or can you just do the?
No, you have, that's how you start. So, because, right, in order to have a max or a min, right, the x and the y components of the gradient's got to be 0, right? So the tangent plane is parallel to the xy plane. So if you set this equal to 0, can you see that? Okay, let's just take some shortcuts here. This, oh,
Oof. Let me make sure.
gotta equal that then, right?
Oh yeah.
Correct? If you set it equal to 0, can I just write that?
Yep.
And then if you set this one equal to 0, the numerator gotta be 0, so therefore x squared plus y squared plus 1 times 2 times ax plus by plus c times b gotta equal ax plus by plus c quantity squared times 2y.
Does that mean x and y has to be the same number? I don't know.
I don't know. Okay, let's divide by the 2's. I can divide both sides by ax plus by plus c to took. Okay, now what do we do?
But can't you like
Is it
divide?
A equals X and B equals Y?
What do you mean divide?
Oh wait, never mind.
Or like divide both sides?
Yeah, you can, so yeah, now it's because I was thinking,
Wait, can you
Wait.
set them equal to each other?
Does
what do you mean?
Like move them.
Like you
all
can
the-
solve for x squared plus y squared plus 1 in this equation and this equation
Is it
and equate those two.
A
Yeah.
equals X and B equals Y? Does that make sense?
No, she's saying that because if a is x, then the
Oh,
x.
and c equals 1.
Wait, Ha said
Wait,
if
no.
x equals a
Yeah, A
and
equals
b
X.
equals y,
That's
X
all
equals one.
easy, but is it right? Or is it?
yeah, it is.
See, we don't have to do work. Did you do all that? Did you actually do
No,
it all?
I tried to skip this.
Oh.
Oh.
We actually worked it out, but no, but what Ha says is correct. Just look at it, right?
Well, I don't think everyone.
Wait, time out. If x equals a
Yeah, wait.
and b equals y, no, that's not the same thing.
Why?
It's not, right?
Wait, why?
But why not?
Because over here,
Oh,
you're gonna
no,
get a
there's
squared
Fine.
plus b squared plus c,
And no, there's actually a and b on this.
and then you got a 1
never
there.
mind.
No, so, oh no.
Oh, that's.
It was almost, but no. So, no, that doesn't work.
Yeah.
So, I guess the strategy here is, oh my gosh.
He actually
AX.
So these are the two things I'm thinking of. Solve for x squared plus y squared plus 1 in both equations and equate it. Or solve for ax plus by plus c in both equations and then equate them. Or,
Wait, isn't?
wait! I thought I got some,
Wait,
yeah, no,
A
look.
equals B.
Why don't you solve for this in both equations? We didn't do this last time, right? So in the first equation, what is that equal to? No,
Wait.
Oh no, Ray.
no,
X over.
x over a.
What? What's X?
No, he just divided the.
Take this and move it on this side, and then this a comes here, you get x over a. And then in the second equation, what is that thing equal to?
Oh,
So
two.
X over-
Oh, there's
Yeah.
X. I see.
What?
Y
So-
over B.
Y over b. Oh, we didn't see that. So now it's easy, just solve for y. Y equals bx over a, plug it in. Plug it back into one of these. Okay, pick one.
The first one.
The first one, okay, so here we go. So yeah, this is gonna be way shorter than we did last time. Why didn't I think of that last time? That means, am I smarter than I was before? I don't think so. Okay, so.
Are you talking to yourself?
Yeah, I am. Y. So what is y squared? B squared, I gotta concentrate now, over a squared plus 1 times a is equal to ax plus by, which is b times this, b squared x over a plus c times x. Now you can solve for x. Now you have an equation with only x in it. Okay, how are we gonna solve for x? What shall we do? Wait, before we move on, did I do that correctly? No sense doing work if it's wrong, right? Is anybody gonna even check me? I mean, I think I did it right.
I believe.
Yeah.
Okay, let's make a least common denominator here. So this is gonna be ax squared plus b squared x squared plus a squared times a is equal to, I guess we should make a least common denominator on this side. So you're gonna get a squared x plus b squared x plus ac x. Yeah.
You put A. Why is it AX squared instead of A squared?
It's AX squared.
Say that again? Okay, look.
No, right here. When you made a least common denominator, you only put AX squared over A squared.
Yeah, I got the a squared right there.
Okay.
Plus a squared. Okay, now is it right?
Yeah.
A squared plus b squared x. Okay. This a cancels that a. Multiply both sides by a. That cancels out. So what do you have left? A squared x squared plus b squared x squared plus a squared is equal to a. Oh, look at that! Plus b squared x squared plus acx. Katoosh, 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 katoosh. X is equal to a squared over ac. X is equal to a over c. Yeah!
Could have done that in one.
Okay. Now what?
And then you plug it back into here to figure, oh, I just tore something, I think. Y equals b over a times x. Y is b over c.
He tore something.
Okay, so, and this is the stationary point right here. This is the stationary point. Oh, this is way faster than we did. No, for real, it took the whole board.
Oh, then you plug it in back.
And then you take these two things and plug it back into here. Okay, I think that one, this is not that hard. You guys can take that and plug it in there, yeah? I have a feeling it's gonna come out nice with the answers right there. So that's the key to the problem. You gotta notice that this over that, you can get the same in both equations so you can equate them. Wow! What? What about the video?
Yeah, how have you not learned something before by kicking the board?
You can.
I don't know. But cause I remember last time when we did it, we didn't notice that, so we just like multiplied it all out. I think we solved for y in one equation and plugged it into the other. But yeah, wow, I like this problem. Maybe we'll see something like this on the test. Look, we got 25 minutes left. Why can't we go on to the next section then?
You said you were tired.
Wait, are you
Yeah, but
gonna
I'm
pause the video?
rejuvenated after doing that problem.
Do you even do
See,
it?
When you actually do a math problem and you come out with the answer, then don't you feel good?
Well, you didn't come out with the answer.
I did!
That's not the answer.
No, but, okay. No, but just to get that far. Okay, I'll finish it
Like
then.
halfway
I'll
through.
finish it then. Okay, so A times X. I fell into your trap because now I'm just doing the problem, right? B over C plus C squared
Like that.
all over A squared over C squared plus B squared over C squared plus 1. All we gotta do is simplify this. Okay, here. A squared over C plus B squared over C plus C quantity squared all over, let's make a least common denominator in the, oh, can you see it already? Can you see it?
Answer is a squared plus b.
Yeah, I know what the answer is. So like over here, make a least common denominator. Can you see it?
Yes.
So like this denominator gonna be C squared, gonna cancel with that C squared, so you got gorilla squared over gorilla, so the answer is just gorilla. Woo! That's fun.
I'm so rejuvenated.
That's because you didn't do it, you're just watching me do it.
So,
Go redo
Are
it
you gonna
right
show
now.
us the video you said you're gonna show
What video?
us?
Oh yeah, you said
The
you were gonna
three
show us a video.
people,
Oh yeah, my wife sent it to me.
Hey, good job.
So is that gonna be today's lesson? Watch
Yeah.
this. Watch this.
Right, this week's been
He's so
really long.
distracted.
Okay, but I gotta go into my email. Don't look at my email!
Nike Zoom Run.
Nike.
No, that's not it.
What is that?
No, see, at the Museum of Math, they had like in the wall, they had light, like a plane of light, and then they had the, you know, the cone. So you can
Oh,
intersect
that's
it with like
actually
to get the
cool.
conic
That's actually
section.
really
So
cool.
like, see
Yeah.
how
Oh,
right
that's
there,
cool.
get the ellipse?
Yeah, that's actually super cool.
Oh, you went there?
No, now that you're describing it. Wow, doing your mouth could be cool.
Oh, this is fun. Is it a big museum?
It's right.
What
Can
are
you,
you
can you open that last picture?
No, that's the front of the Museum of Math. The
You look
door,
thrilled to be
the
there.
doorknob is like a pie.
Why do
He's
you
so
only have
excited.
11 emails in total?
He deleted that.
I don't want to have. I just want to have email that fits in the first screen. Anyway, here in the bathroom. Look how neat the bath. Look at the bathroom sink. You have a pentagon, but it goes into a triangle.
Oh, okay.
That's the bathroom at the Museum of Math.
Aren't like normal sinks, they just do oval to an oval.
No, but this is the Museum of Math. This is the Museum of Math.
Oh,
Wait, look at that, isn't it? Come on, that's pretty neat, man. That's pretty neat.
What's the first one?
Oh gosh.
More map.
Oh, this is a picture of. I don't know. My wife took that one. Just geometric shapes, I suppose. Okay, let's click to download.
Go to the top right, the arrow button. Top right arrow. That one.
Oh, yeah. Well, then it's not done yet, yeah?
It might be.
Just press it, just press it.
Wait, can the camera shoot like what we're looking at?
They missed everything you showed
Yeah. Yeah, too bad. Did it? No, see, it's not downloaded yet.
No, just press it. You can see the progress. Okay, yeah, there you go.
Hey, it's kind of.
Oh, you learn something every day.
You know yours?
This better be the right one,
Why?
because there's two movies. That's why.
You should start downloading the other one then.
Can you do that?
There you
You
go.
can
Yeah, you
download two
down-
things at once.
Okay.
So,
Yeah. Oh, you're so excited. You're so excited.
Okay, wait. Before we show it, can you? Is there a way to rotate it?
No.
My wife took it on her phone. That's why.
Oh, she vertical? She will put it vertical.
Oh here. Sorry.
yeah, if
This
you,
thing up in the upper right hand corner.
if you turn the screen 90 degrees.
Just turn this vertical.
I don't know.
I did all my
Cannot.
bio homework the other day. You do the bio homework?
Which-
One where it's all sideways.
Mhm. I just locked my screen.
I just didn't do it. Because
Really?
I left my iPad at school, so I was
So
gonna
you
do it
have
on, I was
so
gonna
you
do it
have
on
one
my
assignment you're
Snapchat.
doing now?
Okay, you guys just gotta turn your head then. Okay, ready?
You can turn the camera.
I wonder if there's any sound for this.
No sound. We.
See how when you typed in the strings, look, it's a hyperboloid of one sheet.
What?
Oh, your wife must have been like, what a child.
Oh, I
She
feel
like
like the other one was cooler. The one
Other
with
one.
the lasers or the lights.
Really?
Yeah. Wait, you can only make
That
a
was
hyperboloid
cooler.
of one sheet. You can't make anything else. Like a paraboloid.
Well, that's what they had there. Okay, I have no idea what this movie is.
2 minutes.
What?
It's going fast.
Yeah.
I don't think that's in my bag though. It's in my bag.
No, it's going slow.
I don't
Someone,
think
someone
The
on
time
their
is
iPad,
getting
that's why.
more.
Someone's on their iPad, that's why.
Stop being your
Why, does that matter?
Yeah.
I mean, marginally. Like,
Especially when there's like a surge of students using their iPad at the same time, like at the college.
there's not really like one person who does
What if I plugged it into the wall?
Yeah, but
That'd be
you
faster.
don't have your computer plugged into your wall.
Yeah, it is.
Oh, yeah.
What you?
It's good, it's better, but it's better than just using Wi-Fi. Okay, somebody.
So, okay, you know what? So can I save it? You know that thing? Can I save it onto my computer?
Yeah. You already downloaded it.
Here
You
you
just
go,
go to
it's
your
already
downloads.
saved. So you just need to go on your media player and then just open it again. And yeah. You have the media player.
Okay, I'm not sure what you said, but
The
Just
media
go
player is
to
do you see you know Firefox?
this one right here.
Yeah, so
So I had the old video in there,
yeah.
like this. Yes.
And if you close the window you can just open that app again and then
See that again?
like
Can't you just like right click it or something?
so
Or you can just go to your downloads.
just try exit out.
No, go to your downloads. That's
Yeah.
easier.
What do you mean downloads?
Just go to
Right
that Windows
This thing.
Yeah.
Yeah.
Videos.
Oh, downloads.
Yeah.
Or, no.
It should be on there.
You can arrange it by date. Like, go to organize on the top left.
Organize.
Oh, wait, what?
Layout.
No, it's
Oh,
not
maybe
there.
not.
No, that's the way that all the apps. Well,
For folders or.
Maybe.
Like, press something else.
If you go to a different layout, you can definitely do it.
look. This mechanism is called the hyperboloid.
So is this the new movie we're watching now?
No, it's
No,
not.
it's your
It's a
open.
different one.
No, it is. This is a new.
Oh yeah, because it doesn't show the whole thing, yeah?
Yeah. So I told my wife, no, the important part is you gotta see the
Oh,
hyperboloid.
so-
So this is just rubbish. This one.
It's very, I like your shoes.
It's my tennis shoes.
Yeah, it's nice.
Wait, are they actual tennis shoes or like, tennis?
No, I play tennis in those shoes.
What's your word?
Alright,
Decided
alright.
to go to the bathroom.
Okay, we did all of that, and you guys weren't even impressed. So it was like for nothing.
No, the
I was
other
very impressed.
picture is super cool.
You like the conic section?
Yeah,
Yeah,
that's
I
super
like
cool.
Really?
I was